Welcome back, everyone, to Chem 102. My name is Professor El Hawari, and today we will be going over experiment number 5, which is called thin layer chromatography. So, the first task, what we want you to do is make a copy of the lab report template. So, here is the lab report template. Make sure to write the objective that we talk about uh, for the lab video, and then you are going to fill your equipment and function section. Next, you are going to fill out this data table based on our experiment for today for the thin layer chromatography. And last but not least, you are going to write a paragraph that summarizes this experiment. We'll be revisiting each section right now. So, again, you can either make a copy of the Google Doc that's posted on Brightspace and edit the doc, or you can download the document on your computer and edit it and then re-upload that as your lab report. So again, the first thing you want to do, put your name and date at the very top of your lab report for experiment number 5. Now, the direction states that we want to write one sentence that clearly describes the goal, what we hope to accomplish, and the method used, how we plan to do this to complete the experiment. So, a possible objective is in this experiment, we hope to separate and identify the components of a mixture by observing their movement on a thin layer chromatography plate using an appropriate solvent. Again, our objective is to separate and identify the components of a mixture by observing their movement on a thin layer chromatography plate using an appropriate solvent. So pause the video, write down the objective in your lab report. Now let's talk about the equipments and their functions that we'll be using in this experiment. The first equipment we'll be using is the TLC plate, which stands for thin layer chromatography plate. The plate is a flat plate coated with a thin layer of adsorbent, usually silica gel, where the sample mixture is applied and separation occurs. If you look here in the slide, you'll notice that the TLC plate is this white strip, is this white plate right here, where we are going to place our samples, and we're going to see some separation of our mixture. The second equipment is the developing chamber. If you can see, the TLC plate is sitting in a chamber. This is the developing chamber. So it's a sealed container that holds the solvent. The solvent, again, as we said in the last lab, is the mobile phase, which is the liquid that will be traveling up the plate. Now, this allows the solvent vapor to saturate the environment and carry the sample up the TLC plate. So the second equipment you want to write is the developing chamber. The third equipment is the mobile phase itself, which is the solvent. Now, the solvent is the liquid that is going to move up the TLC plate by capillary action, and it will separate the components based on their affinities, uh, either to the solvent or to the silica, which is the stationary phase. And we are also going to be using forceps. Now, we talked about forceps in lab number 1. Forceps in this experiment is used to handle the TLC plate safely without contaminating the surface. So if we want to remove the TLC plate, we will do so using forceps. Now, let's review the theory behind chromatography. Now, we did talk about chromatography in the last lab, column chromatography. It's very similar. The ideas that we talked about in the last lab are very similar to this lab. The only difference is that column chromatography is used for usually separating bigger samples, and thin layer chromatography is used to separate smaller samples. So again, chromatography, chroma, the prefix chroma means color. So this refers to a group of separatory methods that involve the use of a stationary phase and a mobile phase that separates substances based on their color. Now, the stationary phase is often a powdered solid, now alumina or silica, that can interact with various components of a mixture, as we did see last experiment, and we're going to see the stationary phase again in this experiment. And the mobile phase is the liquid or gas, but in our experiments, it's usually a liquid that carries the mixtures through the stationary phase. Now, some components of the mixture could dissolve better in a certain mobile phase and are therefore carried through the stationary phase more easily. So the mobile phase is often the solvent. It's called the solvent. And the last definition we want to go over in this slide as a review for our lab is thin layer chromatography, abbreviated as TLC. This is a method used to determine the purity of substances. So, this is a quick way to figure out, is my substance pure or is it a mixture? If it's a mixture, you'll begin to notice the separation of different layers, and these layers are shown as dots on the TLC plate. And if your substance is pure, you'll only see one dot. So it's used to determine the purity of substances, monitor the progress of chemical reactions, and also used to identify unknown substances. Now, let's talk about a simplified view of how this chromatography is going to work before we show you an experimental video. So, as we know that various components of a mixture are going to interact differently with the stationary and mobile phase. We've seen that last time, and this is based on intermolecular forces of attraction. Some compounds are more attracted to the silica plate, and other molecules are going to be attracted to the solvent or the liquid that is traveling up the plate. And the distinction or the relationship between these two interactions allows us to separate the mixture. Now, the differences in these interactions, as we say, they cause the components of a mixture to be carried through the stationary phase at different speeds. Very important, and this is the reason that we are able to separate these components. One thing is that you may think of it as the mobile phase and stationary phase are competing for each component of the mixture. If the stationary phase wins, the molecule is going to be traveling very slow, and if the mobile phase wins, the molecule is going to be traveling at a much higher speed. It'll try to match the speed of the liquid going up the stationary phase. So again, generally the stronger interaction between a component in the mixture and the stationary phase will result in a slower rate of travel, and the weaker interaction will result in a greater speed or greater rate of travel. Now, here are these are the equipments we'll be using. We'll be using a mobile phase, which is the liquid. We'll be using the developing chamber, obviously. Number three, we have the TLC plate. Now, the TLC plate has our stationary phase as a powder onto a plastic or glass backing. Four, we're going to use a ruler, and the reason is we're going to create a line, maybe in 1 centimeter from the bottom, and we are going to place our sample in the middle as a dot. This will be our dye that we're trying to separate into different layers. So the ruler will be used to measure out that line. Five, we'll be using a marker. Now, the marker contains the dye. Again, it's a colored marker. It contains the dye, and the dye has a mixture of colors, and the goal for today is to separate all these different colors. Six, last but not least, we're going to have a pencil, and then pencil will be using along with the ruler to mark this line right here, which will be our starting line. So again, if we look at the diagram on the right, we have the TLC plate. Make sure the powdered side is facing you. The mobile phase or the liquid is going to travel up the TLC plate by capillary action. It's similar to if you put a paper towel in water, the water is going to be traveling up. The mobile phase, the solvent in the chamber, has to be below the starting line so that it can take the die and travel above the line. If we start with the mobile phase above the die is going to dissolve and we will not be able to separate the die. Very important. And one thing also, we are going to create a small dot of ink. It has to be small. If it's not small, we are going to see the results in a second. So make sure it's a small dot. And again, the starting line, we're going to draw it in pencil, 1 centimeter from the bottom of the TLC plate, and we're going to use a ruler and a pencil. So here is the result. This is what's going to happen. Uh, when the experiment is over, the liquid, let's say, is going to end at this line. So we're going to use the ruler and the pencil to mark it off. And we represent this as D5, distance 5, the last distance. Notice we are going to find several spots. When you see several spots, that means we had a mixture. So that means it was not pure. So 4 spots, that means we have 4 different dyes that were present in the initial dye. And again, at D0, this is the initial distance where we put a small dot of ink that we have from the marker. And again, this is the starting line. Now, if your separation is successful, you are going to see different spots. But if it was not successful, you are going to see a streak, and we're going to show you what that streak looks like in a second. And each spot means that it has a specific dye that was present in the original mixture. So every dot tells us an identity of the starting material that we had. And again, the mobile phase is going to carry the sample. The sample that we're talking about here is the dye. It's going to carry it up the TLC plate. The mobile and stationary phases are going to compete for each of the die. Now, the spots that are closer to the bottom, for example, die 1 and die 2, that means they have stronger attraction to the paper or the stationary phase. However, spots that are near the top, like die number 4, right here, they have weaker attraction to the piece of TLC plate, to the stationary phase, but they have stronger attraction to the liquid or the mobile phase. Each spot, as we said, represents a unique dye, which typically has a unique color, which is what we'll see in a second. So for your data sheet, this experiment, we are going to try to separate different dyes. Now, these dyes are all present in the same marker, and these are naturally colored dyes that are present in the marker, and we're going to be using thin layer chromatography. Make sure as we're going through the video, you answer these questions. How many spots did you see? What was the first color of the first? What was the color of the first spot? What was the color of the second spot? And what's the color of the third spot? If you see a fourth spot, write down the color of that spot. And also, if you see a fifth spot, make sure to note the color. Very simple experiment. We're going to use marker ink. The mobile phase or the solvent that we'll be using is hexane ethyl acetate acetic acid mixture. So this mixture will allow us to get the best separation, and the stationary phase we'll be using is silica. The experimental procedure is very simple. We're going to place 5 milliliter of our mobile phase in the developing chamber, and then we are going to obtain a TLC plate, place it on a paper towel with a dull powder side facing up. We're going to use a pencil, mark the line 1 centimeter from the bottom of the plate. We're going to put a very small dot, very important. We're going to put a very small dot of marker at the midpoint. We're going to place our TLC plate in the developing chamber, and we are going to watch the experiment. So let's actually start by viewing the experiment. All right, so here is the experiment. We have to exit, and here it is. Let's play the experiment. So let's start with the experiment. We're going to start by, all right, let's zoom in. Yes. So the first thing we're going to do is we are going to take our solvent. Here is the solvent, and we are going to add it to our developing chamber. So it's being added. Very important. We have to add the solvent first. As you can see, we're not going to cover the entire chamber. All right, now we're going to take our TLC plate, and from the bottom, we're going to take a ruler and a pencil, and we are going to make a line, and this will be our starting position. All right, and we want to know where are we starting, because uh, in when you take organic chemistry lab, you're going to calculate something called the RF value, which is the initial distance and final distance, relatively speaking, that these dots travel. So it's very important to have this initial location. Now here is our mixture, the dye. So notice we're going to take this dye in our marker, just regular marker, and we're going to place a small dot uh, at the center of our line. Now now we should be using forceps, and that's one experimental error. But we're using our hands for this experiment. Again, a little dot, very tiny. We're not gonna make a big dot, and you'll see why in just a second. That should give us the best separation. Now we'll be taking our TLC plate, and we are going to okay, now yes, we gotta use the forceps. We cannot, so in order to not contaminate the TLC plate, take the forceps, and then we are going to lower it into the developing chamber. And it's called the developing chamber because, and again, we lower it slowly into the developing chamber. And it's called the developing chamber because this is where the TLC plate develops. All right, we're gonna just do another experiment quickly, but this time we're going to, instead of a very small dot, it's going to be a bigger dot, and and we'll see what is the difference. So as you can see, it's not a small dot; it's a considerable amount of dye, and we're going to lower it into a second developing chamber. All right, we gotta lower it using forceps very slowly, and then we are going to cover it up. All right, perfect. And then we're gonna wait a little bit and see the results of each. And let's zoom in and see what happens. As you can see, the liquid is traveling up. If you notice, the line was all the way at the bottom here, so the liquid is moving upwards, and you can see the dot is moving as well. So that shows you the dye is being separated. You give it a little bit, and you can see it's traveling up. Notice the dye will never go above the liquid. It will always be below the liquid line. So the experiment, you always want to give it a few minutes to develop. Now look here, when we use a big amount of dye, not a small drop but a big drop, it's one streak. It's not a good separate This is not a good separation because you're not able to see the different dots. But here you can actually see. You got to give it a little bit of time, and you're going to see the different dots. So this is good separation, and this is bad separation right here. See, it's all one streak. You're not able to tell which dye is which or what colors are present. But here, give it a little bit. As you can see, slowly but surely, you'll begin to see the different dots. And in a little bit, we're going to show you um, what this looks like. We're going to zoom in, but we just got to give it a little bit of time for the developing chamber to do its job. But the main thing here is that when you use a lot of dye, it's not good. Not good. You're not going to get a good separation. But when you use a small amount of dye, you are going to get the best separation possible. All right, let's pause here. Very important. So this is the final uh, TLC plate. Now, as you can see, we have 5 layers. What I want you to do now, go back to the data sheet and let's answer the question. What is the color of the first compound, or compound number one? Which one And if we go back to the data sheet quickly, the question says how many spots. So as you can see, we have 5 spots. What is the color of the first spot? Now, the first spot, let's say spot number 1. We're going to start from top to bottom. So the color of spot number 1 is, we see, it looks like it's yellowish. All right. Spot number 2, and again, spot number 1. This is not the first spot from the bottom. This is the first stop from the top. So we got yellow, and then the second spot, the color, as you can see, is blue. The third spot, you might say it's a little bit of purple, and the fourth spot, it looks pinkish. And the fifth spot is a little bit hard to see, but you can see it's grayish, and it also has a tinge of blue. So as long as you write down your observations, you should be good. And very important, which spot has the weakest attraction to the TLC plate? Correct. It's the yellow spot at the top. The spot all the way at the top, this yellow dye, is not attracted at all to, well, it has weak attraction to the TLC plate, as I should say. And the dye that has the most attraction to the TLC plate is dye number 5, which is the grayish light blue dye. This has the strongest attraction to the plate from the bottom because it's towards the bottom of the TLC plate. And you might be asked, which dye has the strongest attraction to the solvent? That will be dye number 1. So dye number 1 has the strongest attraction to the solvent, which is the liquid phase, and has the weakest attraction to the TLC plate. On the other hand, dye number 5 has the strongest attraction to the TLC plate because it's all the way to the bottom. And dye number 5 also has the weakest attraction to the mobile phase, to the solvent. As you notice, this is an inverse relationship. When you have strong attraction to the TLC plate, you're going to have weak attraction to the solvent. So again, this was our starting position, the dot all the way at the bottom. And notice it traveled all, these dyes traveled all the way to the top. Yes, and it was black, the color of the initial dye. And we're able to separate all these colors. All right. So the summary, after you write down you fill out your data sheet, very important. In one or more paragraphs, make sure to summarize the results of this experiment. Write it in full sentences. Avoid using bullet points or sentence fragments, and make sure to write substantial, one or more paragraphs, and make sure to describe any trends that you observed. You got to make an effort to support your statements by referring to the theory that we discussed for this lab. Now, one thing you would want to mention in your lab report is that which spot had the strongest attraction to the stationary phase, and which spot has the weakest attraction to the stationary phase, which is something that we answered on the last slide a few minutes ago. So make sure to pause, go back, get the information so you can write it in your summary. So thank you for listening to the lab. Again, as an announcement, you are expected to do the following tasks. You did the first one, which is watch the assigned experimental video. The second, complete the quiz that's based on the experimental video. And last but not least, make sure to submit the lab report using the template that's on our Brightspace platform. Thank you for listening and see you soon.